Now, you could also go and do the Lewis structure where you give any sets of 2 electrons, any shared pairs of electrons, not the lone pairs, but the shared pairs, get replaced with a line. We don't really need it for what we're about to do, but that is something I taught you to do in the last unit. Depends on what the question asks. If the question doesn't ask for it, then you're not required to do it. Okay? The main thing we need is this right here, where we can see that there are 4 sets of electrons around the central atom. Okay? We're not looking for the unshared pairs over here. We're only looking for these that are shared pairs of electrons around the central atom. Okay? Those sets of electrons right there, the shared sets of electrons. Okay? So what we want to do is to find a 3-dimensional shape now that comes out of having 4 sets of electrons around a central atom. So what is the 3-dimensional shape you always get? What electron pair shape do you always get when you have 4 sets of electrons? What is it? Tetrahedral. And a tetrahedral is going to look like this. You have one line coming straight up, one line coming out kind of like this. It's a little more than 90 degrees and a little less than 120. Okay? Then you're going to have 2 of these over here, or these 2 things over here. Okay? And this triangle means that this leg is kind of coming out toward you. The dotted line means it's going back behind the paper.
Does it matter when you put those things?
In a tetrahedral, it matters that they look like, as far as whether this set over is here or here? No.
Yeah.
No, you could put these 2 things on this side and this on this side.
But they got to be beside each other.
Yeah, yeah. And if y'all, what she's asking, I think, and tell me if I'm wrong, is can you draw it like this? Is that correct? Oh, sorry. Like that? Either one of those is correct. Okay? Either one will work. Alright. So on each of these legs then, there is a pair of electrons. Okay? So I'll put a pair of electrons on each one of those legs. Alright. So this is a flat 2-dimensional structure. We just went into 3 dimensions here. There's a really cool in this context, I think, episode of The Simpsons where Homer Simpson goes from he goes from 2 dimensions in cartoons to 3 dimensions on the cartoon, but he's actually talking about 4 dimensions. Really interesting stuff. Anyway, huh?
What do you put them dots on there for?
Those are the pairs of electrons, the sets of electrons around the central atom. Your sets can be 2 or 4 or 6, but in this case, all the sets are 2. Okay? If I have a double bond, there'd be a set of 4. Okay? Alright. Now what we're going to do is to draw this same structure. I hope you're doing it in pencil. I'm going to do part of it in pencil so you can see what I'm doing. Take this same structure and redraw exactly the same thing. Okay? I'm going to put my electron dots in pencil because that's what I've got to replace. Alright, so I'll put those electron dots out there just like this structure here. We draw exactly the same thing. What I want to do now is take any shared pairs, any of these dots, sets of electrons out here that are shared, and replace them with the atom that belongs there. So in this case, all the 4 sets of electrons are shared. So I'm going to replace all 4 pairs of electrons, okay? So let's erase those and put our atom up here on each of these. Okay? So now, we've gone from an electron pair shape to this. And since there are no more electron pairs, this is a molecular shape now. This is a tetrahedral electron pair shape. This is a tetrahedral molecular shape. Okay? Got that? Remember that from last unit? I don't see anybody's head going up and down and nobody's saying yes. I hope you remember it.
No.
You don't remember that?
Yeah.
Some people saying yeah. Okay. We did a lot of this in the last unit. Say what? I couldn't understand you. No, we're not ready to do that yet.
We did a lot of this.
Huh? We did a lot of this in the last unit, yeah.
Not that right there.
mean.
No, but we made three-dimensional structures.
Oh, yeah.
Yeah.
Alright, so what's the point of making them?
Because this is what you have to do before you can figure out whether a molecule is polar. Alright, now what are the two conditions for a polar molecule?
Unbalanced.
Unbalanced.
And they gotta be polar.
And polar bonds, okay. Is this molecule unbalanced? No. This has an even distribution of bonds. Every bond has another bond at 109.5 degrees. So it's evenly distributed, isn't it? All the bonds are exactly the same. They're all silicon to bromine bonds. So we can't have both conditions because one of the conditions we already know doesn't exist. Yes?
How would it be, how would it look if it was uneven?
Just be patient. I'm going there right now. Okay? What now?
I know.
A tetrahedral has 109.5 degrees. All tetrahedrals have 109.5 degrees between the angles.
But how would that be even? It's not looking at it.
Because
109 what?
109.5 degrees.
Like, it's
Anytime you have...
can't show how it looks uneven because they'll...
I'm getting to that. So I could figure out whether the bonds are polar, but it won't matter in terms of figuring out whether the molecule is polar. Does that make sense?
Say it again one more time.
I could figure out if the bonds are polar,
Yeah.
but I don't need to figure out the molecule is polar because I already know it's not polar. And it can't be polar because I got to have two conditions. We already know it doesn't meet one of them. Right. It's got to be uneven, and it's not uneven. Okay? Do you want to know if the bonds are polar? Does it matter to you? If you're curious about it, I'll show you. Yes. What I'm about to do now, you don't have to do if you already, well, unless the question asks you for it. The question may ask you if the bonds are polar. Then you have to do it. But if all I ask you is if a question asks you, is this molecule polar, doesn't ask you anything else, then you could stop right here and say it's not polar because it's not an uneven distribution of bonds. What? This molecule is non-polar. I don't yet know if the bonds are polar. I don't need to know if the bonds are polar. If all I want to know is about the molecule. Yep. If your molecular shape is tetrahedral, no, that's not entirely true. Because sometimes if I have a different kind of atom up here, it would make it polar. A tetrahedral that has the same kind of atoms all the way around, that would always be nonpolar. Yes.
So that's non-polar.
That molecule is nonpolar. I do not yet know if the bonds are nonpolar.
I thought it was polar. Because it was even. Okay.
To be a polar molecule, you've got to have both conditions. One of the conditions is an uneven distribution, and the other is polar bonds.
So this is what my question is. What is the uneven distribution?
Let's do another one of these molecules here, okay?
Can you just tell me what
I'm going to show you by doing the next one. Okay?
Oh, so you ain't showed us yet that it's uneven.
This is not uneven. So it can't,
So therefore it's non-polar.
it's nonpolar.
I said it's polar and uneven.
Alright.
That's what I'm saying. Okay. If I asked you said uneven.
Okay, let's look over here on our periodic table with electronegativities. And let's look at the element right next to silicon. Let's look at phosphorus. Okay, there's phosphorus right there. Okay, and let's build a molecule with bromine and phosphorus now. Okay, bromine and phosphorus. Okay. Huh? Yeah, let me start this up here first, okay? Do I need to go through all the sharing arrangement stuff with you guys? Can I just, are you okay with that part?
Yep.
How about do I need to start with the electron dot formula?
Yes.
Alright, let's start with, here's the electron dot formula you get from all of that. You need to be able to do it now, but if you do the electron dot formula correctly, you should get something that looks like this. Alright, so there's the electron dot formula for a combination of phosphorus and bromine.
How do you know it's uneven?
What?
How do you know like that it's even in the middle or not right? Because you
Because then you share the bond.
Well,
Get the part that you said, but you
yeah. It's a lot easier to put phosphorus in the middle because bromine only wants one electron and phosphorus needs 3. When you do the whole sharing arrangement, it should work out that way. Okay? Alright. Yeah, I haven't finished them out yet, you're right. Okay? Alright. Now, what's the central atom? How many electrons around the central atom? How many sets of electrons around the central atom? 4 sets. What is the shape we get from that? Tetrahedral electron pair shape. So let's do the here's a set, here's a set, here's a set, and there's a set. Okay? Alright, so we're going to have a tetrahedral electron pair shape. And we're going to have dots on each of those legs, if you will. Okay? And there's a tetrahedral electron pair shape. We just went from 2 dimensions to 3 dimensions. What? Okay. And then the next thing is we want to redraw this exact same structure. Okay? Now we're going to, well, first thing you're going to do is draw it exactly the same. So I'm putting my electron dots on here. Then I want to go back to this arrangement here, this Lewis dot structure, and see how many sets of those 4 electrons have atoms shared there. So how many of those sets of electrons are actually shared with another atom? Well, there are 3 of them. So I need to put bromines on 3 of these legs. It doesn't really matter which 3. It doesn't matter which 3, but it's easier to see the final structure if I put them down around the bottom. Okay? So let's put bromines on these 3 down here. Alright, if we're finding molecular shape, we're not done yet. Up here, we were done at this point because when we got to this point, we'd already gotten rid of all our electron pairs. But down here, we still have an electron pair left.
So you can't do like this, huh?
That's right. So now we got to draw the same structure again. Draw the same structure again. Actually, I shouldn't do that. Let me do it down here. Okay. And then, so this is exactly the same. What's going to happen now is, after we've got to this stage, we're ready to take this set of electrons off here. Okay? So we erase them. Those electrons are gone. Now we have a molecular shape. Alright, let's review our names. This was a tetrahedral electron pair shape.
Can you write that down there?
It's a tetrahedral electron pair shape. This is a tetrahedral also. No, this is not molecular yet. If we still have electron pairs on there, it's not molecular yet. This is a modified electron pair shape. Modified. Okay. But now this last structure, we did get rid of all the electrons. So since all the electrons are gone, then this is a molecular shape. Okay?
So like, would you ask us what happened to those last electrons or something?
It's possible, I don't know.